Hello, my name is Joe Marzullo, and I'm going to show you how to measure your arrows for the AFC program, Arrow Flight Control. We've all used FOC in the past to estimate what we need to do, but it's just that it's I think a fairly rough estimate, and it doesn't address the things that we really need to know, is how much control we have achieved or how much control we have not achieved. So the tools that we need are a yardstick. I like a yardstick because a tape measure keeps on winding up and gives you a problem keeping up with it. Piece of string to get a balance point of the arrow. That's a lot easier than doing a sharp edge because it's always falling off. And here it is. It's a piece of string and it's already made a mark for you. And a piece of paper with the information that you need to write down. It's very handy to do it that way because if you're like me, you're going to forget half of this stuff when you get to your computer or to your smartphone, and you're going to lose the dimensions. So what do we need to do? So let's measure an arrow. So we're going to use a yardstick against a stop. Doesn't matter what, as long as it's a good stop. We're going to measure overall length. That's from the point to the end of the nock. We don't subtract anything. It's a projectile, and the whole length of it has to be considered. So there's one number that's looking at as 26, and then I want to know the distance from the point to the center of gravity, which we've already established, and that's about 10 1/4 on this one. And then we want to know the dimension from the nock to the center of the fletching. That's pretty easy. And if it's a broadhead equipped arrow, you need to know the dimension from the point to the center of the broadhead blade. This is only an estimate on your part, but we can use common sense and estimate it pretty good. Now all those dimensions, what I would do is make up a little sheet like this ahead of time and then write down the elements that you need. If a field point, you only need 3 dimensions. If it's a broadhead, you need 4 dimensions. It's not complicated at all. The program does all the work for you. Now what you're going to see when you do a field point, we'll say a field point arrow, and here's the same kind of build, the same point weight, and you say, well, it's going to fly the same, and you're going to find a number. I'm just going to invent a number right now. I'll just say that the fletching control force is 30% greater because of the center of gravity of this one and the fletching position. Now you build an arrow with a broadhead, and you're going to see that this number, this fletching control force, is considerably lower than on your previous build with a target, even though you have the same weight point. Reason being is the fletching provides a certain amount of control force, and it's a stabilizing force because it's on this side of the center of gravity. The fixed blade broadhead is just the opposite. It's a destabilizing force. It's flying through the air. The air is trying to push this up, and it's destabilizing the arrow. So to get the real stabilizing force, you have to subtract the destabilizing force from the stabilizing force, and it will give you a net stabilizing force. You don't have to worry about this. The program does it for you. What it's going to tell you is that now your previous arrow with 30% is going to be a heck of a lot lower. You're not going to get 30% increase in control force anymore unless you change some things. And the program will show you how to do that. And it'll be pretty accurate. It's not 100% because there's variations in fletching sizes and broadhead blade sizes, but it'll be pretty darn accurate, and it'll give you a very, very good indication on what you need to do to achieve different control forces. So I hope you use the program, and it gives you a lot of insight on how to control your arrow in flight.